So you want to build an AI chatbot for your website. It sounds like a great idea, a helpful assistant for your visitors, always there to answer questions. But here is the big detail most people don't realize until they are deep in the project. The chat part is easy. The real challenge, the part that becomes a total maintenance nightmare, is the knowledge. Your bot knows nothing about your website, so you have to feed it information. That means you are hunting down documents, writing scripts to clean up data, and constantly worrying if it's all up to date. Because the moment you change your website, your chatbot's knowledge is stale. A price changes, a new feature is added, and suddenly your chatbot is confidently giving out wrong answers. You didn't build an assistant, you built a chore you have to babysit. But what if we could skip that entire nightmare? What if we could build a chatbot that needs zero maintenance? A chatbot that learns directly from your live website, so its knowledge is always current. No manual updates ever. Today, I'm going to show you exactly how to do that, and I built the core of this chatbot in less than an hour. We will do that using a tiny framework called Pocketflow. It's just 100 lines of Python code, but it gives us a really simple blueprint for our chatbot's logic. And because Pocketflow is so simple, we can just let a coding agent like Cursor implement the chatbot and write almost all of the code for us. And this combination honestly feels like cheating. And that's how we can build the entire thing so quickly. So let's dive right in. Let's build a smart zero maintenance chatbot from scratch. So let's talk about how we actually build a chatbot that knows your website. It really comes down to two main parts, the chat interface and the knowledge. Building the chat interface itself is actually the easy part. You just call an AI model like GPT-4, give it a question and some info, and it writes a nice reply. Now the hard part is the knowledge. Your chatbot has to know your website's content, and this is where you see two totally different ways of doing things. The old way uses a method called retrieval augmented generation. You start by scraping your entire website, then you load all the content into a special vector databases. Now these vector databases become your chatbot's knowledge brain. But the problem with that is that it's a copy. And the second you update your website, that copy is out of date. To fix this, you have to scrape and synchronize everything all over again. And this is a constant maintenance headache. Now, in contrast, our way is much simpler. We don't make a copy. Instead, we build a smart AI agent that reads your website directly in real time. Let me give you an example. Say a user asks my website, how do I get a refund for product A? Our agent starts on the home page. It sees the keywords refund and product A. Then it navigates to the product A page and reads it. It finds some good information like a 30-day warranty, but not the actual refund steps. So it needs to think. It thinks like a person would. The refund policy is probably in the support section. So it goes there. On the support page, it finds the refund policy links, reads that page, and gets the exact instructions. Now it can combine everything into a perfect, complete answer. So this like reader agent gets fresh knowledge every time. The website is its brain. So there's no database to maintain. So next, let me show you the chatbot in action. So many of you may remember my service that turns any GitHub repo into an easy to follow tutorial. You can check out my earlier video on that if you haven't, but it generates these amazing detailed tutorials like this one for model context protocol in just 5 minutes. Now, this is fantastic for learning. But what happens when you are reading and you get stuck on a concept? You can't ask static web page for clarification until now. We've added our new AI chatbot to this tutorial page in the right bottom corner. So when I'm learning this MCP here, maybe I get confused. For example, what is the real difference between sampling and the true use in this context? So I can just type the question into the chat box, Could you explain the difference between sampling and tool used in MCP, like I'm 5? And there it is, a perfect simple explanation that helps us understand right away. It makes the whole learning process interactive. You can ask follow-up questions for any concept in the tutorial right when you need help. So you are probably wondering how you can get this onto your own website. It's actually damn simple. It only takes 2 steps. Steps 1, I have a service called askthispage.com. I will just paste the URL for my call tutorial page right in, and it generates a small snippet of JavaScript for me. Step 2, you just drop that JavaScript code into your project. So for my call tutorial webpage, I simply paste the JavaScript right into the layout TypeScript, and that's it. The chatbot is live, and if you ever not sure where to embed this script on your project, you can just ask a coding agent like Cursor, where is the best place to add this script to my site. I have another YouTube video that goes into more detail on using service like this, so check that out if you are interested. So the tool makes it easy to deploy, but the real technology is the live reader agent running behind the scenes. Next, I will show you how I can build such a chatbot very quickly. It comes down to 2 key ideas, a tiny framework called Pocketflow and an approach called agentic coding. Alright, so how do we build this live reader agent? The secret is the tiny framework I wrote called Pocketflow, and when I say tiny, I mean it. This is the entire source code. It's just 100 lines of Python code. It is so small that you can read the entire thing and understand exactly how it works. There are no hidden complexities and no black boxes. So at a high level, Pocketflow provides a simple graph abstraction for building AI workflows. It has a few key concepts, but instead of me just explaining them, we can ask our AI chatbot in action. This is the Pocketflow documentation page, and this is a chatbot that I built using the exact method we are talking about today. So let's ask it the question. Explain the 3 core concepts of Pocketflow: node, shared store, and flow. Okay, and you can see it working right there. It is crawling the documentation live to get the full context before it answers. Pretty cool. And here is the answer. Let's walk through what the chatbot says. It starts by saying there are 3 core concepts: node, share, store, and flow. First, the node. The bot defines a node as the smallest fundamental building block for a single task, and it highlights the 3-step process each node follows. You have pre-processing, where each node gets its data from the shared store, then execution when it performs its main computation, and finally post-processing, where it writes its results back to the shared store and crucially decides what to do next by returning an action stream. Next, the shared store. The bot called this the central place where all nodes can read and write data. It acts as the communication backbone, and here it shows a simple example. The shared store is just a standard Python dictionary. You can see keys like user queries, document content that nodes can read from, and other keys like summary that nodes can write their results back to. And third, the flow. The bot explains that a flow is the orchestrator. It's the directed graph that defines the sequence and the logic among these nodes. It shows you how you can connect nodes. You can have a default connection, use the double arrow operators, or you can create a connections for specific action strings. This allows for branching logic, and it gives this great example of a more advanced workflow. It shows a start node going to a middle node. If the middle node returns the action continue, it moves to the end node. But if it returns error, it branches off to a separate cleanup node. This is how you can build really robust, complex logic. So this is a solid explanation generated completely by this chatbot. Now let's see if we can write a complete runnable program for us based on these concepts. Let's ask, can you give me a minimal code example of using Pocketflow to build a simple program that takes a number, adds 5, and then multiplies by 2? Okay, great. It just wrote the entire program. First, it defined the add5 node. Its preprocessing method reads the input number from the shared store. Then in the execution, it takes that number adds 5 and returns the results nice and clean. Finally, in the post-processing, it takes the results and writes it back to the shell store, but under a new name, intermediate result. This makes it available for the next node. And you can see the exact same patterns in the multiply to node. Its pre-processing methods gets these intermediate results that the first node created. Its execution method multiplies it by 2, and its post-processing method writes the final results back to the shell store. Then down here, it sets up the actual run. It creates our shell data dictionary with input number of 10. It creates an instance of each node, and this line here, a node, double arrow, multiply node, that's the blueprint, that's the workflow. It tells the flow manager, run the add node first, and then run the multiply node. Finally, it creates the flow and runs it. So let's just run the code and see what happens. And there it is. Just as we designed, input time, intermediate is 15, and final is 30. So that's Pocket Flow. Damn simple, right? A few basic building blocks that let you map out any workflow. But what about building the more complex nodes for our chatbot, like a web crawler or a more decision-making agent? That's where the second key idea comes in, the agentic coding. And the concept is incredibly simple. You design and AI builds. So we believe that in the age of large language model, your job as the developer shifts. You are not focused on writing line after line of boilerplate Python code. Instead, you should focus on being the architect. You design the high-level system workflow. You think about logic, the data storage, the steps your AI needs to take. And then you hand this design over to a coding agent like Cursor, and let it handle the whole implementation for you. And this works super well for one key reason, because Pocket Flow is so simple and transparent, AI agent can understand it perfectly. There are no complex hidden abstractions for it to get confused by, and sees these simple pre-processing, execution, post-processing patterns and know exactly what to do. Now, to make it even easier to get started, I've put together a project template on GitHub. You can just go into Cursor, select clone project and paste the link to this GitHub template. And boom, you have the entire project loaded. The template includes a special rule file, so Cursor immediately understands the entire Pocket Flow framework. You can even test it, just open chat and ask, what is the Pocket Flow? And it will give you a perfect explanation. The template also has a design document template. This is where you work. You don't jump into the code, you stay here at the high level. You simply describe the nodes you need and the logic that connects them in plain English. You design the system and let AI implement the actual Python code. This allows you to build any complex large language model project, whether it's our chatbot, a RAG pipeline, or multi-agent system at incredible speed. Now, this combination, a simple large language model framework that AI can understand, plus a large language model agent to do the tedious work for you. Honestly, it feels like cheating. So next, let me show you the exact agentic coding process for our chatbot. All right, so we are set up in Cursor with our project template that understands Pocket Flow. Now let's put on our architect hat and design the flow for our live reader chatbot. First, I'm going to switch Cursor to agent mode. I find that powerful models like Google's Gemini 2.5 Pro or Anthropic's Claude 4 work really well for this. So let's give the agent our high-level design prompt. I will type, help me write a detailed design document for a website chatbot using Pocket Flow. The core idea is that it should crawl a starting web page to understand its content. If it doesn't have enough information to answer users' question, it should intelligently decide which links to follow and continue crawling until it finds the answer. First, just write the design document and stop there. And boom, just like that, Cursor populates our design document. This is our blueprint. Let's walk through what it came up with, because this is the most important step. First, the flow design. The agent correctly identified that we need a loop and start with a crawl and extract node to read these web pages. The results go to an agent decision node, which is the brain. If the agent needs more information, it signals the explore and loops back to the crawler. If it has enough information, it will signals answer and moves to the draft answer node to write the final response. Now, this is a perfect, simple, and powerful workflow for our goal. Next, it identified the utility functions we will need. These are our agent's hands to interact with the world. Of course, we need a core large language model utility to talk to the AI. Plus, we need a web crawler utility to read the web pages. So for the web crawler, Cursor initially used just a simple requests, but I changed it to using Playwright. I find it much more reliable than a simpler tools because it controls a real browser, so it can handle more complex JavaScript and lazy loading content much better. I do want to mention that this approach has its limitations. For instance, it won't work pages behind a login or a capture. For those, you kind of need to build a customized logic for them. Now for the shared store, this is the centralized whiteboard for our agent. The AI has designed a grid structure. It includes places to store the user question, conversation history, and a master list of all the discovered URLs. It also has the URL content to store the text from each page. And this is where our state will live as the agent works. And the last but not least, the node design. This is where it breaks each worker's job, so let's look closely. For the crawl and extract, it correctly identifies this as a batch node because it needs to process multiple URL at once. Its job is to take a list of URLs, call our web crawler utility for each one, and then post all the extracted text and new links back to the shared store. For agent decision, this is like the brain. Its pre-processing step gathers all the context, the user question, the conversation history, and all tasks we've crawled so far. The execution step is where the large language model call happens. It will ask the large language model to make a simple choice, whether it is answering the question directly or explore more. If it chooses to explore, it also needs to say which new links are the most promising one to visit next. And finally, you have the draft answer node. Its job is very simple. Its pre-processing method gathers all useful text and the agent has identified. Then its execution step makes one final large language model call to generate a clean, well-formatted answer for the user. Okay, this design is perfect. Now for the fun part, let's ask the agent to implement it. And this is our agentic coding process. And here we go. The agent is now taking our blueprint and writing the actual Python code. It is creating the Pocketflow nodes, importing the utilities, and handling the logic for reading from and writing to the shared store. This is the power of agentic coding in action. Let's maybe take a look at how the agent decision node is actually implemented, as it is the most important part of our agent. So instead of its execution method, it's all about this prompt. The code constructs a big prompt for the large language model that includes the user's questions, our crawled web page, knowledge base so far, and the list of visited URLs. Then it asks the model to make a choice between answer or explore, and to explain its reasoning in a structured YAML format. Now, this single prompt is what drives the agent's entire decision-making loop. Then in the post-processing method, the code simply looks at large language model's decision. If it's explore, it updates the URLs to process our short whiteboard, and it returns the explore signals to Pocketflow. If it's answer, it just returns the answer signal. All right, let's run these things from the command line to see our agent sync for the first time. So let's ask our chatbot to answer how does an agent work in Pocketflow. Perfect. You can see the logs here across the initial Pocketflow GitHub page. The agent decision node reasoning said it had enough information and generated a great answer. And just like that, we have a working agent brain. The key takeaway here is that as the developers stayed at design level, we make these architectural decisions, and AI, guided by the simple structure of Pocketflow, can handle the tedious implementation work. Now, this system is also incredibly easy to augment. Let's say we want to add a new capability like escalating this issue to a human. We will simply update the design document to include a new escalate action and a talk to human node, and let the agent help us implement that logic. So we have the brand, but how do we connect this to a chatbot bubble on a real web page? Now, this is the final piece of the puzzle, and it's easier than you think. Let's look at that next. All right, so we have our intelligent live reader agent. We've designed the flow. The AI has helped us implement the code, and we've seen it run in the terminal. That's our powerful AI brain, but the brain is currently run on our backend. Now, for this to actually work on your website, we also need to implement the front end. We want a chat bubble that your visitors can see and interact with. So let's talk about how we connect our brains to a face. So the high-level architecture is really simple. On the backend, we already provide this server.py script in our open source repository, and its job is to wrap our Pocketflow agent in a web server so it makes it accessible over the internet. On the front end, we have this chatbot.js, which creates the chat interface on our website. Now let's actually look at the key pieces of the code. It's much simpler than you might think. This is our backend server.py. We are using a lightweight framework called Fast API. See this part here, at app.websocket API WS chat. This creates a single endpoint like a special URL that our front end can connect to. Now, when a messenger comes in, this function gets the user's question. It then sets up the share store dictionary for our Pocketflow agent and runs the flow. After the agent finds the answer, the server simply sends that answer back to the front end, and that's all the backend does. Receive a question, run the flow, send the answer. Now for the front end chatbot.js, this is a code that lives on your website. The key function here is this send message. When user clicks on send, this function grabs the text from the input box and packages up the question into a JSON messenger and sends it to the WebSocket URL on our backend server. This is the same API WS chat endpoint we just saw. Then it just listens. When the server sends a message back, like a progress update or the final answer, this onMessage function catches it and calls addMessage to display the bot's response in the chat window. It's just a simple loop. Send a question, listen for the answer, and display it. The rest of this file is simply the UI code for a nice looking chatbot. I should mention I didn't code all this UI by hand myself. I just asked Cursor to write one for me, and you can do the same. Now, to make this super easy for you to try, we actually provide a default backend that's already deployed and run for our free service, askthispage.com. You can use it to get started immediately without setting up your server. But for a real production website, you will want to host your own backend using this server.py file from our repo. This is important because it gives you full control. You can use your own API keys, choose different AI models, and enforce any customer logic or security you need. So with this simple front end and a back end, we have a full functional, zero maintenance, and customizable AI chatbot running on our website. From a high-level design to a working product, all in less than an hour. All right, so let's wrap this up. We started with a common frustrating problem and built a solution that I think is pretty cool. And there are three main things I want to take away from this. First, the best knowledge base for your website chatbot is just your website. Letting the chatbot read your own website live means you never have to worry about the stale data again. This is the key to make a zero maintenance chatbot that actually works. Second, you don't need a huge, complicated framework to build smart AI. Using something tiny and transparent like Pocketflow gives you a simple blueprint for your agent's logic. It's easy to understand, easy to debug, and it works perfectly with other AI tools. And the third, use agentic coding. Let an AI agent write code for you. Seriously, you should learn this if you haven't already. It's a 10x productivity boost. You need to focus on the high-level design, the architecture, the logic, and let an agent like Cursor handle the tedious implementation. It's a game changer. So yeah, that's the whole system. No more babysitting your AI chatbot. You have a chatbot that just works. If you want to build this yourself, all the code is open source on the GitHub repo. The link is right down in the description. Thanks for watching. I will see you in the next one.